Welcome back. This is the second lesson recording for IM2, October 8th, 2020. So let's get into dilation and similarity, and we worked on dilation last lesson. So we're going to extend that to how it relates to similarity. So let's think about what is similar. When two things are similar, we say they are same shape but different size. So for example, these two giraffes, they are similar. Or these two balls, they are similar. Or these two people, they are similar, even though they are different size, right? What about these three pictures? Can you pick out which ones are similar and which one is not similar? Well, number 1 and 2. 2 is just a bigger version of number 1. Number 3 is not similar. Why? Because it's only been stretched horizontally. So it needs to be stretched both horizontally and vertically proportionally. Okay, so 1 and 2 is, they are similar, but 3 is not similar. Okay, so to study similarity, we are going to focus on polygons first. Why? Because straight lines are easy to measure. And then we'll go further narrow down to triangle, because they're the smallest of the polygons. So how are dilation and similarity related? Well, the definition of similarity is that two polygons are similar if there is a sequence of rigid transformation. Remember, rigid transformation is reflection, rotation, translation, plus dilation that carries one onto the other. Okay, if it's just two rigid transformation, they are congruent, but when you combine rigid transformation plus dilation, then the two shapes are similar. So the working definition of similarity is all corresponding angles have equal measures and all corresponding sides are proportional. Remember, corresponding means same relative position. Okay, same relative positioned sides are proportional. Same relative angles are equal measures or equal or congruent. So let's check for similarity here. Remember, we said that all the angles, the corresponding angles, needs to be congruent and all the sides needs to be proportional. What do we mean by that? Well, what we mean is that okay, so we need to make sure that corresponding angles have equal measures first. You see the 53, 53, and 53, they're congruent. Okay, the next one is 81 and 81, they're congruent, and 78 and 78 degrees are congruent. And then finally 148 and 148 are congruent. So all the corresponding angles are congruent or equal in measure. Okay, corresponding means same relative position. Okay, so this position and this position, they're relative to each other, they're the same, right? Now we need to check the corresponding sides are proportional. So okay, so when we look at this 4 here, which is the corresponding side? It's 12. Okay, so the 4 over 12 needs to be proportional, and 4 over 12 simplifies to what? When you look at 4 over 12, looking at the equivalent fractions, I can divide this into 2 and divide this into 2, divide into 2 more. So I can actually divide this by 4, divide this by 4. So that becomes 1 over 3. Okay, what about the second side? If I was to look at 6 and 18, 6 and 18. So if I was to look at 6 and 18, 6 over 18, okay, make sure that you are starting with the same shape first. So smaller to the bigger, 6 over 18 is really simplified to 1 over 3 because both numerator and denominator are divisible by 6. Let's look at the next one, 3 and 9. Okay, I don't want to write 9 over 3 because I always want to start off with the same shape. So I'm comparing the small to the large, so it's going to be 3 over 9, and I can divide both the numerator and denominator by 3, and that is 1/3. And then finally, let's do the last one, 2 over 6. 2 over 6, I know I can divide both numerator and denominator by 2, or the 2 are the common multiplier, and that becomes 1 over 3 again. Okay, so notice at this point, okay, all of them have 1/3. They all have to be 1/3. It's not good enough that 3 of them are 1/3, but one of them is 1/5. They all have to be 1/3. That means that all corresponding sides are proportional. Okay, so let's go on to the next one. Okay, so please answer in private chat, are the two polygons similar? Why or why not? Please work through this same way that I did. Okay, we're not given any angles, but check out the proportionality of the sides. Okay, I'm gonna please pause the video and do this now, and I'm gonna assume that you've done so. Okay, let's check this out. Let's start with this 12 and 24. So that's going to be 12 and 24. That's divisible by 12 and divisible by 12, so that becomes 1 over 2. Okay, what about the next side? Okay, what about this side? 15 and 30, 15 and 30. That's divisible by 15, 15, so that's really again 1/5 again. And then 30 and 60, 30 and 6 over 60, that is also equivalent to 1/2. And then finally 24 over 50, 24 over 50. Is this same as 1/5? 1/2? It is not 1/2. Okay, or I can say that this is really same as what? If I simplify it, that actually becomes 12 over 25, which is not the same as 1/2. Okay, so because this one of them is not 1/2, the whole polygon is not similar. Okay, if one fails the proportionality test, then it's no longer similar. Okay, so that's not similar. Okay, what about this one? Can you pause the video and ask yourself, are the two polygons similar? Why or why not? Okay, no, it's not, because the angles can be different. Why? Because we're not given. Okay, the sides are proportional because the scale factor is just 2, right? If I multiply 15 by 2, it's 30, 15. So the sides are proportional. But remember what we saw before, that this looks like 90 degrees, but this could actually be 89 degrees. You can't sort of just trust your eyes and say, oh, they look like the angles look the same, so therefore they have to be the same. It could be slightly off. If it's just a little bit off, even 1 degree or even 0.1 degrees off, then they are not congruent, so they are not similar. Remember, this could even be, this could be 30 here, 30 here, 30 here, 30 here. But because when the angles are different, they are not similar. Obviously, this shape and this shape are not similar. Okay? All right, are the two polygons similar? Why or why not? Come up with a counterexample. Counterexample meaning that, can you think of a polygon with 90 degrees, 90 degrees, 90 degrees, 90 degrees? can you draw one that is obviously not similar to the one that you're starting off with? Okay, pause the video. I hope you had a chance to think, and this will be an example of a counter example. So because this rectangle, they still have 90, 90, 90, 90 degree as their angle, or I can say that they do, but obviously this rectangle is not similar to this square. So that's a counter example that says just 4 angles alone, the corresponding angles being congruent is not sufficient for polygons. Okay, so remember, we need both the corresponding angles to be congruent and all the corresponding sides to be proportional. Okay, so how to check for similarity? All corresponding angles and have equal measures and all corresponding sides are proportional. So how I would do that is I would start by making sure the angles are congruent. Okay, so I see that 75, 75, 2 arc here, 2 arc here, and 1 arc here, 1 arc here. The angles are good. We need to make sure the corresponding sides are proportional. How would I do that? So I would find, okay, what does CA? CA is referring to this side. Okay, which is the side that is corresponding to CA? It's actually this side, right? Okay, so CA over DO is, what is that? CA, the length is 10 over 15. Okay, so that's one side. Let's do the another corresponding side. This and these two sides correspond, which happens to be 80. That's the first left triangle, followed by the right triangle OG. That's the side length. Remember, when we use 2 letters to denote the side length. So that the measure of that is 6 over 9. Can I simplify this any further? You can divide this by 3 and divide this by 3, and you are left with 2/3. I should have done the same thing with the top one. Divide this by 5 and divide this by 5, and I get 2 over 3. Okay, and then lastly, I do need to do the third side because I need to make sure every single corresponding sides are proportional. That's CT over DG is, and the measures are 8 over 12, and again I can divide the numerator by 4, denominator by 4, and you're left with 2 over 3. Okay, what about when the triangles have different orientation? Well, we need to first match up the angles to be corresponding. I said 61, 61, 30, 30, 89, 89. So the angle seems to be good, okay? But what about the corresponding sides? To do that, the easiest way is to rearrange it by redrawing this triangle that looks like this. Okay, so once I've redrawn it, and then it's easier to match up the sides, and I've matched up the sides and found the proportion to be 1 to 4. Okay, so I'll continue with